everybody, and I'm glad I got the opportunity to go and share what we've been able to accomplish leveraging open access. Where we've been gearing towards is, from the full electronic design process, co-design has become a really key issue from the, product design cycle side, and we'll share a little bit of how we're using open access to address that co-design. Just a little bit about Zuken. Zuken has been in the industry for over 40 years, and we've been focusing mainly on advanced packaging and printed circuit board design, and with over 1,300 employees worldwide, global company. But based on what our customers are doing, we've kind of expanded out to different areas. So if you go to the next slide, please. So along with advanced packaging and PCB, we've extended ourselves more towards the system side and offering solutions for the cable wire harness space. So really looking at how we could support not just the consumer and the IoT and other markets, but also automotive, big data, defense, mil-aero, other markets as well. So, and along with that, that comes with what we also offer with engineering data management, or with data management that supports that. So this is just a little bit of background on Zuken. If we can go to the next slide. All right, so challenges. What are we seeing in challenges today? So at the moment, in the grand scheme of things, we have tools that are being used, from the chip design side. We have different tools being used for packaging and different tools being used for printed circuit board design. And as we all know, we all go through it on a day-to-day basis, is that in the process, there's just a lot of gaps on how we communicate. It's very manual and error-prone. And we're using, non-engineering methods to figure out how to, drive, DFM checking, or managing net names across systems, or doing proper ball development or bump planning for your systems. So, these are some of the challenges that we're looking to address from a co-design perspective. So if we go to the next slide. And the other issue is that we're seeing is that during the design process in itself, when we're talking about going from pathfinding or feasibility studies to production design, there's just a lot of gaps in that process to begin with. Also, we're seeing a rise in a lot of complex RF module designs, specifically for the IoT and automotive market. And, with the, constant increase of, I/O pin density in the system, what we're basically seeing is that we're trying to solve 3D problems, even from a pure physical construct point of view, with 2D tools. And what we really need is a native 3D data model of the system where you have designing and concurrent simulation available at the same time, which can handle that delicate balance between doing the pathfinding and production design. So how do we do that? So if we go to the next slide there. So when we're going down this path of how to solve that problem, I think one of the key things that we looked at is how to enable this chip package board co-design is that, we need to shift the process from, that's been traditional from a chip or board level to more of a product-centric approach. And we felt that because of the complexity of the designs, we also need to include a mechanical aspect as well, whether it's the mechanical from a package point of view or just even like an enclosure or other mechanical features in the system. With the way miniaturization is taking place, it's a key element that we needed to consider. And also, again, having a native 3D environment, 3D design element viewing is the key for being able to visualize the full system. And when we talk about bridging, as we know that the database structures between what's in a package or a board is just way different from what's on the chip side. So whether we're talking about the actual IC design or doing even an interposer, having a system that allows you to kind of manage a very flexible flow to do your I/O management, RDL routing constraints is critical. So these are some of the examples of just key elements that we thought that, what are we going to need to enable this whole true single unified co-design environment. So if we can get to the next slide. So as part of this, we also looked at how we can go through, and also how do we manage the data from a data exchange standpoint. So we have open access, which I'll kind of talk about how we embed, but also when we talk about, passing a lighter data model for co-design, and now that you have a system, because we're leveraging open access for more of that chip level resolution, but now you have a whole system in place. How can you exchange that? So we've been working initially with IEEE and JADA for this format called LPB, and we're looking to work in the co-design work group as well to see if we can help support it with the efforts that we have here with a unified data model that has the information for the net list, the geometry, the component information, the design rules and such. So so I'll explain about how we're using that as well. So if we can go to the next slide. So I think one of the key elements here is that as we look at the data structures in that co-design environment, from an actual design process point of view, where people struggle is how do you manage the ECOs between the chip, package board, interposers, or anything else you have in the system. So what we're looking at is that in this unified environment, being able to bring in the chip, the package board together, being able to take a snapshot or generate a golden net list, we want to be able to help drive a process that when you have data exchange taking place or your design decisions being that are happening at each stage. So just take, for example, one of the things that we're always run across is, on a chip, if you move the die bump location, how do we know that the footprint on the package database has been updated properly so that any kind of IO swap or location of a die bump is synchronized? Today we're just sending emails and spreadsheets and stuff, right? That's not an efficient method, right? So we're looking at how do we manage the ECOs and how do we make sure that we check and approve any kind of issues around or managing the synchronization across all the domains that you may have in your system. So this is some of the things that we're looking to solve downstream with the co-design environment. And if we can go to one more slide. So the goal from us is to take advantage of open access to get to that unified environment. So what we've done is, and I have the videos I could share with you guys if possible later, is that we have one environment where you could take all your chip databases, your interposers, your packages, your PCBs, and put them together in one system, and not just view them, but you can actually start authoring against all three domains in one environment. And we were able to actually achieve that by taking the traditional data model that's on the package and board side and embedding open access within that environment so that we can very easily manage the chip level data or the interposers within these systems. So that way, whether we're talking about ball development or net assignments or managing chip shrink issues, the DFM constraints, all of that becomes now seamless because it's all within one environment. And that allows very intelligent trade-offs and planning that goes through the process. And it actually allows us to bridge a lot of the gaps also between feasibility to production design in this approach as well. So if we can go to the next slide. So what I had here as an example was really just showing off where on the right side you have a picture where you have PCBs, you have several packages, you have interposers, you have chip data. Actually, these ICs also include TSVs, and the video really articulates how we have a wizard that allows you to go through and define the connectivity and the relationship, because as you know, what we're labeling for signal nets on a chip data versus a package or a board or anything else are just completely different. The engineers are defining it differently. So how do you mitigate that? So we have wizards that go through and create system level electrical nets and then creates one full system assembly view, and then allows you to start actually allowing concurrent designing, doing live trade-offs across the system. If you make a pin swap on a chip to a package, then you can also propagate that to a PCB as well. So we're able to really take advantage of open access and open the door to actual true co-design methodology in this kind of environment. So I guess if anybody has more questions or wants to know more about that, I'd be more than happy to share that offline. Can we go to the next slide? So in here, what I was going to show is that once you have the full system in place, and if you want to do it from a system view or even from a, again, just from a planning perspective, we have the ability now, because of open access, to go through and, bring in, some initial starting point of the chip data. You can then go in and bring in the package. And then the goal we're trying to do is working with other partners in the industry is, if we can help optimize seamlessly to say you could shave off an RDL layer or you could reduce package layers for your devices, I think everybody in here, depending on, what kind of volume that they generate their devices, what kind of cost savings that is, right? And then also when you work with different members of the industry, let's say, one of the companies we work with, they just want to know if what they're sending out to their SAT is going to be correct. Right, so if SAT comes back and say, hey, this is going to take 18 layers on a package, you want to at least have some upfront idea that this is what it's going to take. So this kind of environment allows you to very quickly go through and, implement your, what we call, the die tiles or I/O cells, and you go through and optimize, do your RDL routing, do some package routing, and it's all following all your, tape out rules. And you go through and start having better predictability and accuracy, and you can then reuse that as part of your actual production design. So that's just a little bit more about how we're actually taking advantage of the open access environment. So I think that might be the last slide. Yeah. So any questions?
You can unmute your phone with *6 if you have any questions.